Alrighty, we've been talking about arrays. I'm still going to talk about it. Looking at this little code snippet here, I'm not going to really look at it for very long, but I see that they have something called valid items and something called valid prices. Now, when I was doing my parallel array examples in the last few times, I did them something like this. What lecture are we on anyways?
I think Q.
That sounds right. All right, so, and I forgot something that the book always has us do, and so I wish that I'd made my examples look like this. But the book likes to do it like this, to where if you have an array, you define a variable that has the length of the array. So if I had two parallel arrays that look like this, you know, names equals Bob, Sam, and Tim, and then I had another parallel array, well, a parallel array with it that had their ages in it. Bob is 40 years old, Sam is 30, and Tim is 45, something like that. And then I think I showed you to do it like this. For I in range, len names, colon, like that. And then I would print out the names at that position, and then the ages is at that position. And so that would print out that Bob was 40, Sam was 30, and Tim was 45. Now, what the textbook does is it shows creating a variable that tells you, let's see, where is the lecture? Here we go, right? The number of items and the number of prices. And so they have a variable called size, which is the size of those two arrays. Now, we don't really need that variable because in this particular language, and in a lot of languages, but not all of them, you can ask the array itself how long it is. And so that's what we were doing here. We were saying, okay, how many names are there? That's what we're going to count to. But if we're going to do it the book way, we might do it either as, you know, size equals 3, and then we could put size there. I prefer to base this for loop based on the actual size rather than 3. Why is that? Because now that I've set that to 3, if I come in here and I decide that we're going to have one more person in here, Zach, right? It's no longer valid, is it?
No.
But that's the way that the textbook shows it.
Which one do you want? Which one would you rather?
I would rather you do it the way that I've been showing you. But I just wanted to point out that when you look at the textbook examples, they're going to look a little bit different because they're hard coding the length of the array in a variable. Like
well,
that.
I'll just use my notes because I think the other way's
right. Yeah.
Or it looks like it would pose less trouble.
Correct.
Point, you have to make corrections.
And so the way we did it in the other lectures is just to put the len and then the name of one of the arrays there. Doesn't matter which one as long as they're the same length. Now we could kind of accommodate kind of both ideas and done this and do this, where we said instead of size is equal to 4, we could say that size is equal to the length of the names array. And at least then we don't have to change that number each and every time. So we do have possibilities there, but go for it. If the language lets us do it that way, let's go ahead and do it that way, in my opinion. Now, the reason the textbook shows that is because in some languages, when you declare the array, you have to give it a size as you make it. Okay, if we did, we would do that, but we don't have to, so we're not gonna. Or certainly don't at least have to. So here they have a little routine. Where they have an array and then they ask the user to enter an item number and then they look up, is that item in the array? And if it is, they print out the price of it. If not, they print out a message saying that, you know, it wasn't found. Something to that effect. So we could play with an idea like that. Let's go into here. Where's idle? I have too many windows open right now. And I'm trying to remember if we did it for this class or if I did it for another one where I had an array, you know, that was like an inventory number and things like that. But that's where I'm going to go with this, like so that you have an inventory, an ISBN number or an item number, and then a book title and then a book price. Mm-hmm. So item num equals, and we're going to have like make up some numbers. And we're going to have some item names. Bread, milk, eggs, and oatmeal. And then we're going to have some item prices. Bread costs $1.99. Milk is $4. Carton of eggs is $1.50. And the oatmeal is $2.50, whatever. And so they have a loop going on asking what item number do you want to look up? And if we find it, then we'll print out the price of it. So to make this a little bit more interesting, perhaps, maybe we'd make it so that we'd give them a choice of commands to do. And then based on those commands, I don't know. I mean, this example right here is such a short amount of data that it'd be silly not just to print the entire list, but there could be 8 million items, right, in our list. So let's go ahead and do it that way. So what are we going to do? Let's firstly print our array for I in range, len, item underscore num, close, colon. But there's nothing wrong with taking that idea that we did, that I mentioned a little bit up. So instead, I'm going to do that the size of the array is equal to the len item underscore num. And then so this statement is going to say for I in range, parentheses, size. So I'm going to print out. Now I was tempted to go back into formatting it, you know, and making everything of the same width and stuff like that. And then I've decided, I don't know. It seems like it's a lot of typing and it starts to look complex. I would like to. Oh, let's do it. Let's do it. Well, let's do it both ways first. So first we're going to print out the item num at that specific position. And then we're going to print out the item name at that particular index, that particular subscript, and then we're going to print out the item. I don't know why I use this as plural and the rest of them singular, so I'd rather be consistent. So I'm taking the S off that. Okay, so now when it runs, it should print out our bread, milk, eggs, and oatmeal list, or excuse me, parallel arrays. Right, and there we go. So I do want to take a stab at trying to make it look a little bit pretty. And here's what I'm going to try. I'm going to use that F quote idea where I say, please print out the item num, that's a curly brace, position I, and I want you to make the item number 5 spaces wide, followed by the item name at position I, and that one, how about 10 spaces for it? We may wind up with a food name that's up to 10 spaces long. And then how about the item price at position I, and we're going to use a very specific format here to say that we want the item price to have 2 decimal places. So dot to F. F because it's a floating point number because it's got decimal places, and a dot followed by the 2, meaning that we want to preserve 2 places after the decimal point. I think I talked about that before, but I'm going to show it to you again. If I have a number here, X is equal to, and I want to print that to 2 decimal places, I would do dot to F like that in order to do it. So that's a floating point number, X is a floating point number, and we want 2 places after the decimal. And that's what we got. And if we wanted, 4 places after the decimal or whatever, then we would change that 2 to 4. So, and if we put a $sign there in front of it, it'll make it look even prettier still, right? It'll look like dollar prices. And then an end quote, and then an end parentheses. Now, like I said, every time you start trying to format the data and make it pretty, the output is pretty and the code is ugly, right? It's just pretty much a fact. So anyways, now we have our cute little table. I don't know any way of making it look easier to read than that, unfortunately. The only alternative would be to do it a way that looks like this, and I'm not sure if it's easier to read or not. You could take a gander at both of them and decide which one was easier to read. %5s, because it's a string, this item is a string, the item number is a string. And by the way, I could have been putting S here to mean that that was a string, and S there that means that was a string, but it didn't really matter what kind of data it was until I needed decimal points. And since I needed decimal points, I did have to tell it that it was a numeric format, that it was a float. Anyway, so %5s, %5s, this one that might actually be cleaner looking. And then this one, our floating point number, %.2f, end quote, %. And then in here, we list our variables, our item number, our item name, like that. That almost is easier to read.
And just a minute, what did you copy to put in there?
I copied them from here. Item number I, item name I, and item price I.
All right. Okay. Thank you.
Sure.
Okay.
And of course, there's even another way to do it. And I'm not going to do, so 4 different ways of doing it. So this is kind of like the raw dump of data. It wasn't nicely formatted at all. This one is not going to put the $ in front of it yet because I left the $ off. But as soon as I run it and make sure it works, I will.
I'm getting
Okay,
a
so
syntax error. I don't know. I'll go back and find it later.
let's see. Well, you can always comment it out and go back to the one that worked.
Oh, okay.
And I said %5s, but this one was supposed to be 5 wide, but this one was supposed to be 10 wide. So my output didn't look right. All right, so what's your error? What is the syntax error saying?
Well, let me run it and I'll tell you. It says not enough arguments for format string. I must have left something out.
Well, that means that you have more % than you do
Oh, okay.
things in between the parentheses. So there should be 3 placeholders.
Okay, I've got that. Oh, I do have an, okay, I've got the one. I don't have a paren before item.
Okay, so yeah.
Let me see if that'll do it. Unexpected EOF while parsing.
And go and put the other parentheses at the other end here.
Oh, yep, that's it. I'm missing it. Okay. Oh, great, it worked.
All right, cool.
Great.
Okay, so I've been doing this style. They borrowed this from the C programming language invented back in 1970. So I've been doing this forever. So this one looks real familiar and comfortable to me. If you like the way that looks better than you like that one, whichever one looks better and is easier to use. I don't have a preference, and I haven't asked you to make any pretty printed tables at all. I'm just giving you examples of them so that if you have to do them in the future, then you know where to start sniffing to find your answer.
Okay.
Oh, forgot to do the rest of their little example. Say that they didn't have that nice little menu in front of them telling you their prices, and so we wanted to let them pick an item number and display the price. So we would need a while loop of some kind. So choice is equal to something, empty string, whatever, and while choice not equal -1, colon, let's ask them what they want to do. Choice equals input, parentheses, quote, enter the item number to view or -1 to quit. And then we're going to need a function that will search through the array to find that item number. It needs to tell us whether that's at 0, 1, 2, or 3. So if they type in 444, I need to find out that the item number, that the index number that I'm interested in is a 2, right? So I need a function that if we pass in 444 and this list, it'll return 2 back. Why 2? Because item 444 is eggs with a price of $1.40, and that's what they want to see. So we could write a little function like that. Python may give us a little function like that. This example here has us write one. Oh, they just have a simple for loop that goes all the way through it. Why not? First, though, if we're going to check to make sure that the choice is not equal to -1. So if choice is not equal to -1, and by the way, I don't like the way that I've structured this. No, I'm just going to give in to the dark side and write this the way that I really would rather than the way the textbook would. I'm going to make it a while true loop. And if you have a while true loop, it's an infinitely repeating loop unless a break statement is encountered. And so when they type in -1, if choice is equal to -1, that's the break. Now we can look through the loop. Excuse me. Now we can look through the data. And if we ever find it, we're going to print out the element for it. We're going to print out all the data for it. So for I in range size, or we could just do that len item nums like we were doing on Tuesday. If item underscore num subscript I is equal to the choice that they typed in. And by the way, I forgot to convert the choice to an int. And it needs to be an int. I mean, I guess a float would be okay too, but it needs to be a number and it's not. So I'm going to have to come back up here and do that. And so now this looks like our more normal input statement. Since the item numbers aren't fractional, since they don't have like 0.2, 0.3, 0.4, they're always whole numbers, I'm going to change that word float to an int. We just normally do float because our data is not usually whole numbers only, but in this particular case, let's go for it. All right, so if the item number is equal to the choice, then we found it, right? And so we could print it out. Print item number equals, end quote, item underscore num subscript I in subscript. I'm going to do the same thing for the item name and the item price. Print item name equals, end quote, comma, item name subscript I in subscript in parentheses. And now forgive me, but I am going to do the formatted print statement just because I want the $ to be right next to the price, and I want to force it to display to 2 decimal places. So print parentheses F quote item price equals $, and now we need our start marking. So I know I'm going to need the curly braces. What are we printing? We're printing the item underscore price at that specific position, subscript I. We need some formatting information, so we're going to put that :.2f to indicate that we need 2 decimal places. And then an end quote and an end parentheses. All righty, I'm still torn as to whether I like doing it that way or if I would rather have done it this way. Print parentheses quote item price equals $, %.2f end quote % open parentheses, close parentheses, and then put the inside those parentheses, put item underscore price subscript I. Now, unless I have a syntax error, those two things are going to do the exact identical thing. So I know which way looks better to me, but that's because, like I said, long experience. Ooh, unmatched parenthesis. I have 3 closing parentheses here and only 2 opening parentheses here. I don't know what I was thinking. So I need to fix that line and put only 2 close parentheses there. All right, so enter the item number 444.
Oh, I see. Okay.
And then enter the item number. I'm going to type in one that doesn't exist, right? It
When
didn't
I
find
entered
it.
444, it didn't work. It worked up to I entered 444.
So it printed out the list of choices,
Yeah,
but then when you,
it did. Uh-huh. Yeah, it looks just like yours, but when I entered 444, I got a print item number. Oh, wait a minute. Well, everything printed out fine until I hit the 444, and then I got a, it says line 50, print item number equals, quotes, comma, item num I.
so is it displaying a syntax error or just nothing?
It says track back. Now, trace.
Oh, so it is a syntax error. Could,
Okay,
Joni, could you do me a favor and snap a picture of your screen and text it to my phone number?
sure.
All righty.
Absolutely.
There should be a green arrow underneath the Zoom where you can share your screen.
Oh, I'm on a different computer. I'm sorry. I'm using 2 computers.
Oh, all right.
Thank you, though, so much.
Yeah, if you could tell me how to do that, because I don't know how to tell the students how to share their screen. So please repeat that.
There's a little green icon with an arrow pointing up. It says share screen right under it. It's right next to chat and record.
You can also push Alt-S to get the share screen up.
Yeah, you can do that as well.
Oops.
I don't quite know how it looks like for the host, but
Right.
I should try to log in on Zoom on.
Oh, well, certainly don't change it for now.
No, I won't. I
And
won't.
sorry for the diversion, everybody, but I want to know how to do this. I need to dial in as a student. That's what I'll do, is set myself up, set a meeting up with myself and figure out how to do it.
Okay. Let me try this again.
So for those of y'all who are giving me feedback and talking and stuff, which one of these 2 ways of printing formatted output is less horrible and traumatic? You like that way or you like that way?
I kind of like the top one more.
All right, that's cool.
Did he pick the top print statement?
Yes.
Now, with the top one, we don't have the formatting, though, right? For the $sign. Is that
And when we
correct?
said,
Oh, he
top
likes that one.
we were
Okay.
comparing that one to that one. They both
Oh, okay.
do formatted output. They both produce the
I see.
exact identical output. They both display the $sign
Mhm.
and they both just limit it to 2 decimal places.
Okay. Okay. Great.
All right, so I never got a picture, Joni. I don't know if you were going to take one.
I just sent it.
Okay.
Did it not get there? It says delivered.
Well, I guess it's going to take a sweet time. I'm going to go ahead and we're going to go on from there. If
Okay.
you want to, go ahead and just comment out the line that it complained about. It
Okay.
complained about a specific line. You can always just choose, I'm going to view my line numbers here. So under option, show line numbers, You'll know which
Oh,
one to
okay.
comment out.
Oh, okay. All right, show line numbers. Oh, line 50, okay. It's the print statement that you have your cursor on that I'm having trouble with, I guess. Oh, I see the problem. I have a capital N instead of a small n on that.
Oh, okay. Good. All right.
Okay. Wow. No, I'm sorry, not a capital N, but I have an extra N in the number.
Okay. Yeah.
Oh, I'm so sorry to bother you guys with that.
No problem. So the thing that one interesting thing to note about this is that it's not telling us if it doesn't find it, right? If we just say enter the item number to view or -1 to quit, I type in a bad number, it doesn't do anything. And maybe that's okay. Here's what I would prefer to do is I would like to see, and this is using some Python specific stuff that the book's not going to show you. I'd like to check to see if the number that they typed is even in the array, is even in the list. And here's how I would do that. So after that if statement, I'm going to do if choice space in space item underscore num colon. Or how about we make it, yeah, I like that. Okay, if choice in item underscore num colon, and then we better tab all this stuff over like that. So I just highlighted all those lines and tabbed them. But if that wasn't true, we need to print out an error. So lined up in the same column as that if keyword, else colon, print item number not found.
The 10-penny challenge. And I don't think I would have guessed that.
So I'm going to run it and I'm going to type in a bad number. And it says the item number was not found. But if I type in a good number, I get to see it. So perhaps a way to clean up the code a little bit would be to, rather than use a for loop, I could just use a function that would tell me the position, right? So that if I type in 444, it would have returned a 2 and I would know which index to do. But using a for loop to search through it is okay. I don't really particularly, I don't think I want to change it any more than that. Press my luck on the number of edits I've been making to get it to work. But I do want to remember the name of the function that will search to see, because this syntax is useful to check to see if something is in a list. So like if I have a list number is equal to 314159, and I want to see if 2 is in it. If 2 in colon, print yes in parentheses, else print no, right? It's going to print no because it wasn't found in it. But if I had put 9 in there instead, if 9 is in the in list, then it would have print yes. I guess that's worth doing as a little example in our code. So if our list is, I'm just going to put some random numbers here. Well, they're not random, right? They're the digits of pi. 3, 1, 4, 1, 5, 9. If 2 in L colon print quote found the 2, else colon print did not find the 2. And now I'm going to copy and paste that and change the 2's to 9's because I know that there is a 9 in there. And so if 9 was in the list, then we found the 9, else we did not find the 9. Okay. But it would be nice to be able to search the list for our target number. And if we found it, then record its index position. And so that's called a linear search. Linear because you're just looking in a straight line, starting at the beginning and going to the end. So what we're going to do is we're going to create a variable called found at, and we're going to set it equal to -1, indicating that we haven't found it. But when we do find it, we're going to set found at equal to the index of the position that we're looking at. So what is our target number? We're looking for 5. We want to find the element containing 5. So for I in range, len, parentheses, capital L, close parentheses, colon. If the item at that specific position, so if L subscript I is equal to our target, then we have found it. So found at equals I. And print found the target. How about we just make it say found the target at index, end quote, comma, I. If we get to this point and found at still equals -1, it means that it was never changed. So if we get down here, then it means we never found it. So if found at equals -1, print parentheses, never found the target. We could have used a tactic like that in order to search the list rather than use a for loop to loop through the list. Now, is this any cleaner than that for loop? Heavens no. But if we had put this in a function so that it could be done with a single call, then it becomes more reasonable to do that. Right, and so it did find the target at index 4. That number that we're looking for, 5, is at position 4. If I scroll up here, I'll see that that's the case. 0, 1, 2, 3, 4. If we could do this in 1 line of code rather than 7 lines of code, it's worth doing. So let's go and remind your instructor how to search the list. So index is an inbuilt function in Python which searches for a given element from the start of the list and returns the lowest index where it appears. Okay, so we could have replaced it with this. Found underscore at equals index. I better go and get this exact syntax. list name dot index. Okay. So L dot index parentheses target. This line of code replaces those lines of code. So here's what we're searching for. So our code to look for a specific item number, I'm going to grab these 4 print statements and copy them and paste them later. So I'm going to grab those 4 print statements and copy them. So I can come down here and I can search. We're going to look for item 444. So we're going to do found at equals item underscore num dot index parentheses choice. And then if found underscore at is not equal to -1, in other words, if it was found, then print it. That's where I'm just going to paste my stuff. Else colon print parentheses quote item not found. Yes, there's a faster way of back tabbing. I could have just highlighted all 4 lines and back tabbed. Okay, so I hope that makes sense. We search the list for our choice, and if we find it, great, print it out. How do we know if we found it or not? If it returns a positive value. I'm not totally comfortable making it not equal -1. I would rather have made it if found at is greater than or equal to 0. Because if it's greater than or equal to 0, we know it's a valid index number, right? Because our indexes start at 0. Up here are items, that's 0, that's 1, that's 2, and that's 3, and whatever. And so anything that it found, it could have returned to 0 if we were looking for 1, 1, 1, 2. So that's valid, but anything less than 0 is not. And usually these kind of search or index functions will return -1 if not found. And so I felt pretty good about making it say not equal -1, but I know of one in particular that returns a negative number that might not be -1. Let's see. No, I'm not trying to learn about coronavirus. Where'd my documentation go? I guess I closed it. All right. Well, anyways, so that seems to work. Why don't we make this another input statement? So choice is equal to int parentheses, input parentheses, close, close, and inside there, quote, one more time, enter an item number, please. All right, so one more time, enter an item number, please, 5656. Ooh, that blew up. List index out of range. Oh, I know why. You see all these I's? That's the variable that those should be. Rather than change all of these to found at, I could change that one and that one to I. But I think I'll just go ahead and do that. Now I kind of wish I hadn't. That looks ugly. Oh well, I'll leave it alone. Okay. All right, I hope that makes sense. I really hope this idea made sense of using a for loop to go through our list, and when we found an index that matched our choice, print out all the values in the matching arrays at that same position. So that's how we search the parallel array and gather up all the information about the related elements. This command here, index, l.index, or, item number.index, or whatever the name of the list is that you're looking for, is a way to search to see the position of that specific value. So if we have colors, red, green, blue, and we want to find the index of the color green, which is I, is equal to colors.index parentheses quote green. And then if we printed it out, I is now 1 because that's its index position in here, right? 0, 1. But if we change this word to red, then I would be 0 because that's position 0. And if we change it to something that wasn't in the list, then it would be -1. Let's prove that. After colors.index, I equals end quote, comma, I. Getting to the point where we're having to enter too many pieces of information each time we run it. All righty, there's a wrinkle. A great many languages will make the index function return a -1 if it's not found. Python just makes it crash. That's not really what I wanted to see. So that means that we would have to validate the fact that it was even in the list first before we started to do any search. And that's making this example look really nasty. So what do I mean by that? If what I'm searching for, if my target is red, I need to validate that it is in the list to begin with before I start searching for it. So if target in colors, colon, now I can get the index of it. I is equal to index, no, I is equal to colors dot index parentheses target. Search the list for that color. And then print, target, comma, quote, found at index, end quote, comma, I. Else, colon, print, target, comma, not found in array. And I keep calling them lists, and I'm sorry, and I've gone on with y'all before about what, the fact that Python uses lists, and we're talking about arrays, but Python uses lists to mimic arrays. All righty, and I would need to do the same thing here. This will actually crash if we type in a bad item number. And how would we fix that? We would need to edit these two statements here. We would need to make this say not if found at greater than or equal to 0. This line's going to have to go away. So I'm commenting it out temporarily if you're following along. And this instead needs to be if choice in item underscore num colon. And then I can take this code here, cut it, and paste it there. All right, now it won't crash if we type in a bad item number. So we're validating. And then we're finding the index. Subscript of that item. All right, so for the folks who like to type along and keep this working, if I totally messed you up, are you halfway along? Do I need to pause here? Have we given up trying to keep it working? Or
Well, I'm confused. Okay, we have choice above there. We have the integer input. Okay, then we space down, and I have found at item. That goes after the if statement instead.
that's correct.
Okay. Okay. And that is find the index. Okay. All right. Thank you.
Sure. So our story tool now, how to define a list, L is equal to, and then you put some items between curly braces. The first element is at index 0. The last element is at n-1, where n is the length of the array. Now, I'm sorry that that's complicated, but you know what I mean. If this thing is, we have these values in here, what is the length of the array? If we typed in LE in parentheses L, the length of the array is 1, 2, 3, 4, 5. So we can access elements 0, 1, 2, 3, and 4. So when you have a list, the lowest element you can access is subscript 0. The highest one is length -1, n-1. If you go past that, you'll get that out of range error. To see if an item is in the list, if item in L, that's how you do it. Or if value in L, or whatever you're looking for, right? To find the index number of an item, to search the array, I equals L dot index of the item. I'm really wishing I hadn't used the word item because it's not an item, it's an element or a value. So I'm going to change those words item to value. So to see if a value is in the, see if a value is in the list, you do that. If value in list. To find the index number of a value, an element, that would have even been better. I is equal to the index of the value, like that. You can search an array with a linear search, which is basically one of those things where you do for I in length of L, if L subscript I equals your target, do something with it, right? That's a real short form of what we did up here with that for loop. Right there.
So this is the short form for all of that.
Right. I'm just giving, like, you know, little thumbnail summaries of what we've done here. And so this is the idea that was embodied in this big block of code up here, right? Where
Wow.
we
Yeah.
got our target. We checked to see if it was in the list. And if it was in the list, then we used a for loop, a linear search to find it.
Okay.
Oh, I'm sorry, for I in range, parentheses, alien, oh, got the word range. Improving search efficiency. The program should stop searching the array when a match is found. So you can set a variable to a specific value instead of letting normal processing set it. Leaving the loop as soon as a match is found improves efficiency. The larger the array, the more beneficial this becomes. Are they going to give us an example of that? Here they have a variable called founded, and they set it equal to n. And then when they finally do find it, they set it equal to something else. I sort of did the same thing in my search example, but let's see here. So they're doing everything with while loops. There's nothing wrong with that. Here's their loop. And they keep going more and more and more until they found it. Guess we'll play with that a little bit more just so that we have our code that looks something like what they've done. We had our colors array up here. I'm just going to copy that and paste it so that I can use it again down here. Not that it would. And what's our target? We're looking for the color blue. Or we could ask the user or whatever. And so we're going to say found is equal to false. Did we ever find it? And they're calling it sub for subscript. I'd rather just keep using I. Oh, okay, fine. So the subscript is, we're going to start at position 0. And while the subscript is still less than the length of the array, we check to see if we found it. If colors subscript sub in subscript equals the target colon, then we have found it, right? So found is equal to true. And so then they want us to modify this loop so that not only do we break as soon as, this is for the birds, I don't want, let's, yeah, so they have a compound expression in their while. While the size is less than the size and founded is equal to no. Whoopsie, come back. All right, so I'm going to change this. While found equals false and the subscript. I don't like the letters SUB. Index. Have to change a few things. All right, so that's our linear search. Classic textbook linear search example. The only problem is that since I didn't use a for loop, I used a while loop, I'm going to have to increment our counter, our index counter. So else index plus plus, or plus equals 1. And then we could make use of that, right? If found, then we could print out the colors at subscript index, in subscript, comma, was found. So what are we doing here? We have an index value that's going to count from 0 up to 1 less than the length of the list, which is exactly what our for range statement does. And it breaks early. It leaves the loop early if we ever find it, because if we ever get a match, then we set this variable equal to true. And so now this is no longer a valid condition, right? Because and means that both of these have to be true for it to continue looping. And as long as the index is less than the length of the list, it's going to keep going. As long as found is equal to false, it's going to keep going. But if either one of these ever become not true, right, once our index grows to be too large, it's past the end of the list, or this becomes, I guess we could do exactly what they did. Instead of using Boolean variables, use words like found is equal to no, and while found is equal to no, keep doing that. And then down here, we would have to set found equal to yes or something like that. All right, so personally, probably using Boolean variables would be a better choice, but this kind of matches their code a little bit close. I think they just use letters, N and Y, rather than no and yes. But I think that's okay. So I hope you can visualize what this is doing. We could draw it out as a flow chart, but that flow chart would look almost exactly like what we have here. We would have the statement while sub less than size, or while index less than size and found it, you know, and then there would be some code where we check to see if we found our valid item. And if we did, we set our variable equal to show that we did find it. And then so when we're done with our loop, then we check, did we find it? Yes, we did. Then we could output something about it. Else we print out some kind of error message. I think we haven't done that. All righty. So that's probably enough about linear searching. And I've shown you like 3, 4, 5 different ways of doing these things. I'm going to show you what I would consider the canonical, the way that I would recommend doing it, right? That's kind of the textbook example. Let's rewrite it so that we have our list of numbers again. 8, 6, 7, 5, 3, 0, 9. And we want to find one of those numbers. So our target is 3. And so we're going to say that our index position of what we're looking for is equal to -1, meaning we haven't found it yet. After heck with it, we're not going to even do a loop at all. We're just going to take advantage of the is keyword and the index keyword. So if target in nums colon, get the index of our target, index is equal to nums dot index parentheses target in parentheses, and then print we found, comma. Now this is the kind of thing where it's actually a nice use for using a formatted quote. Print parentheses, F quote. We found curly brace target in curly brace at index, curly brace index, end curly brace, end quote, in parentheses. Otherwise, if the target wasn't in the nums, so else colon, print F, we did not find curly brace target in curly brace in the array, end quote, in parentheses, like that. Okay. So really, the concepts are the same. It's just that here we're taking advantage of the fact that we have a function that checks to see if it is in the list, rather than using a while loop to go all the way through it and check every value ourselves. And we have a function that does that looping for us to check to see what index it is. So these are the two things that make this code look so much cleaner than this code, right? Because these two lines of code replace all of this kind of logic here about the while loop and the keeping track of an index counter and adding one to the index counter and stuff like that. So this is how I would do a linear search. Smiley. Use the built-in Python functions. I don't see anything wrong with taking advantage of the features of the language, because every language has these kinds of features. They just give them different names. And so the book is teaching to the lowest common denominator of functionality, right? But every language has things that have been added to it to make it work better than just the most primitive examples. All right, let's go look. Anybody have any questions over this, or your code isn't working if you're trying to get it to work, or I've completely lost you, or what?
I have an error on the, it looks like I copied your line 126, the index plus equal 1.
Right.
Mine says index is not defined. And I'm
You
wondering
have
if
this line here.
there it is. Cool. That is it. Yeah, I forgot to change it from sub to the index. Okay,
My
thank
fault. I changed my variable names on you, so I created trouble for you.
you. No worries. Thanks.
You'll put your code on your for this lecture up, right? Because I've got to check some syntax. I think I've copied something wrong.
Okay, sure. Yes, I will.
Okay, thanks.
So out in our week 13 folder. Wait a minute. I think this arrays homework was not. Yeah, that one was actually assigned last week. So let me drag that up. You can let me drag and drop. So much fun. There we go. Okay. So anyways, I had listed 3 videos that I wanted y'all to watch, and I promised a quiz, but it's the world's easiest quiz because it's just like one of those lecture review forms. All it asks is, did you watch it? And if you did you find them interesting or useful? Mention a few things that you learned from the videos. So, right there, you're just going to go in, you're going to tell me that you watched it, and then you're going to tell me what you got out of it, if anything. And it's okay to say, no, I didn't find them very interesting, but I did, get something more about how to count in binary or whatever. So just give me some feedback over them if you would. and then you'll get full credit. As long as you click yes, you did watch the videos, and you get the, the full points for the assignment.
Awesome.
So as far as homework is going, in terms of lists, the last homework that we had was this: write a program that creates an array that is your list of 4 favorite books, write a value-based for loop to print the values in the array, and write a range-based loop. Okay, so you're going to take the same idea and you're just going to add a query ask the user for a name of a book or whatever you made, movies, whatever. If it is in the list, print a message indicating that it is in the array, right? And my computer froze. Please don't freeze. Okay. And then lastly, if it is not found, I want you to append it to the list, which we haven't shown. So I'll just show you right now how to do it. So this is just an expansion of homework 8 with some additional functionality. Homework 9, add this functionality. Ask the user for the name of a book, or if you did movies, then ask them for the name of the movie or whatever. And then if it's in the list, print a message like found at index 3. And we've done several examples of that, right? Our best example probably being right here, right?
Mm-hmm.
So that's what that's going to look like. But if you didn't have it and you were going to append something to it, let's go ahead and append that value to our nums list, right? So our target, we want to nums.append the target.
Sorry about that.
All right. So if you have a list and you use .append and you put the value in the parentheses after it, it adds it to the end of the list. You really can't do that with arrays. That's why Python uses lists instead, because lists can grow and shrink as needed.
Okay, I have a question. If we, okay, we have all those numbers, the 876675309. Okay, and we write this, and then we append. I'm sorry, I'm not understanding the append part at the end.
Well, maybe I should take it out of the assignment. And unfortunately, my machine is frozen, which means
No, that's okay. It's
no, wait,
okay.
no. The machine. I'm complaining because my machine is frozen, and I think I've lost the video.
Oh no.
So
Uh-oh.
yeah. So I'm real disappointed. Anyways, so what this is doing, and what I was just about going to demonstrate before it crashed, is if you have an array name.
Uh-huh.
And when I say it's crashed, I still have my cursor. But if you look up here, you see this. Maybe I'll be able to get it out. I don't know. But this .append command just adds whatever is in the parentheses to the list. So since the target is 3, we would find it. But if this was the number 6, no, that is in the list as well. 2 is not in the list, right? When it did nums.append, it would go to that nums list, and then it would just tack on a comma 2 to get it at the end of the list.
Oh, okay. Okay. All right. So we just run it like it is, and it'll ask you, or it'll append the number you queried.
Right.
Okay.
All right. Well, I can make a Dropbox for y'all on the iPad. That won't require me to have use of the computer.
If we've already turned in our homework, do we just go back and cut and paste it on this homework?
Sure, right. You don't need to rewrite it.
Okay.
All right, gang, out in the week 13 module, there is a Dropbox for this lecture. Feel free to upload whatever you want to in it, and I will see if I can recover this video so that it's not lost, which I would appreciate. Wait a minute. We already had a lecture Q and elemental PQ, so this is really lecture R, and I'm confused. Okay.
Sorry about that.
So wish me luck. See if I can get out of this without losing a video. So I'll talk to you all on Monday. And please, if you have any questions, go ahead and text or call, okay?
All right.
All
Have a
right.
nice weekend. Thanks.
All right, you too. Thanks. Bye-bye.
See you Monday.
See ya. Yes, love?
I wanted to make noise, go out the door and stuff, so I was waiting.
I recorded an hour-and-a-half lecture and the computer crashed. I mean, froze. So I can't save my lecture.